taking the time out to review this video on function notation. After watching this video, you should realize that it's really all about the name. So where do we start? Well, we normally start with equation. A lot of you may have some familiarity with this format. It is an interpretation of the slope-intercept, just not in the normal order you would see it, but it's still that format. So here in this video, we want to talk about function notation. But let's first talk about converting an equation into function notation. Well, if you take a look, you might see a slight difference. Can you see what is the difference between the equation and the function notation? Well, I hope you noticed that it was this parentheses of the x. Yeah, this is where we change our thoughts into talking about input as it relates to the output. So we're trying to get that naming factor into the function notation that we didn't have in the equation. So why do we really want to even go into function notation? Well, it helps us to tell a story. Now, so what does that story encompass? Well, like I mentioned before, when you have function notation, you can now talk in terms of input on like maybe an x-axis, in this example, how it relates to outputs that may be listed on the z-axis as is shown in this function. So according to this function notation here, whenever I pick a point, I will write it in a different format. So instead of saying my x and my y, now I say x, and then this is how it modifies c, which is my output. So we're talking in terms of inputs and outputs. So that would give us more detail with the function notation. And then it leads us into talking about the domain. Now, domain is going to be related to our input, and range will be related to our output. This will help us also pull from this function notation where the value may appear at 2 on the z-axis. And remember, starting value, nothing much we're talking about the y-intercept. So this is another line to our story that we are starting to construct. Also, another storyline could be the rate of change, which is listed as 7, which you might be familiar as the slope. Yes, we commonly use the slope as the rate of change, but as you move forward in talking about functions, we will more detail and refer to it as the rate of change instead of the slope. Can you add anything else to the story? Well, if anything comes to mind, don't forget to write it in your notes, which I hope you started at the beginning of this video. If not, you can always rewind and start over. That's the joy of recording. So let's do a knowledge check based upon what we've just gone over. See, can you answer each of these questions? And I'll pause and give you a moment to do that, and then I'll drag from the bottom. All right, well, let's try it together. Hopefully you already have all the answers filled in, and this is just a recap. So from the story, we indicated that our input value is x. Oh, it looks like I made a mistake. We're not using y in this example. We're actually going to be using c. So remember, you can always change your input value to whatever variable you want. You just have to stay consistent. So in this case, we're not using y, we're out using c, as we indicated here in the function notation. Now we want us to go ahead and evaluate this function for the input 1. So in my thoughts, what I'm going to do is say, hey, I know I see x in a couple places. So wherever I see x, the question is asking me to replace that with the value of 1. So I am going to follow those instructions, and everywhere I see an x, I'm going to put a 1. And that leads me to just evaluation on the right-hand side of the equation. So there'll be 2. I know the product of 7 and 1 is 7, and then that sum will lead me to a result of 9. And my last few questions are going to be based on my answer, and I know the input value that they requested was 1. It yielded me an output value of 9. and my coordinate is going to have my x first, in this case my c second. So go ahead and review that and see if you have any questions. Well, I hope that was clear, so that way you can go ahead and see what are the benefits of function notation. Well, there's several. The main thing is shorthand. It helps us answer the questions without always having to evaluate the equation. So in function notation, let's revisit our answer. If I know C of 1 is the request, and I have it already in my function notation, and I put in my input, I know my X was my input, C was the output, but now I'm putting my computation of my values with 1. Putting that 1 in will yield me with that 9. So on the graph, I can easily take one form of algebraic and convert it directly to the graph. So first, I'm always going to label my axis. I know my input is on the X, that is the horizontal line, and my output is going to be on my C. And it told me one of the points in this function is going to reside at 1, 9. So I'm going to go, always start at the origin. I'm going to go 1 up to 9, and I'm going to drop a point. And hopefully I dropped it correctly right in that corner. And that will help me to graph. So I always start at the origin, go over my input, go up to where my output is. And that'll tell me where the point is on the function. Now, it's not the full function, but it tells me where a point resides on that function. Okay, so let's get some more information so we can fully represent that function on the graph. So going back to our storyline, we're going to go to line 4. And it told us in the function that our starting value is going to be at 2. And if you remember that's to wind this up, you will be correct. So I'm going to go right to that graph, and I'm going to put that second point in for my y-intercept or my starting value in this case. So I'm still on that x and that c axis. So let's go back to the storyline and get more details so we can finish drawing that function on the graph. Well, the rate of change, commonly known as slope, is listed here at 7. So let me go here and ensure that I comply with that slope or the average rate of change in order to plot that graph. So what I'm going to do is I'm going to start at my starting point, go up 7, and then go over 1. I'm going to comply with that rate of change. You know, if I have 2 points on a linear graph, I can do what? Yes, that's right. I can draw a line. And as you notice, I'm not that great eyeballing it, but the great job with tools is that I can always adjust to ensure that my line is intersecting the 2 points that are compliant to that function. So my story has helped me to not only give the information of the function notation algebraically, I've been able to present a visual using the details for that function. Okay, so let's recap this shorthand. Once we evaluated that 1, we got a result of 9. That gave us a point on that function. Once we have a point, we can go back and use that starting value, verify that we use the rise over run, and if you need to, you can always do the look count like we do on the number line to ensure that we're using the proper rise over run, which is 7 over 1. And then I can recap a story. So this is like your cliff notes, if you guys do that on your English class, to summarize. So the recap of the storyline, when I put an input of 1 into the function C, I should yield an output of 9. So that is a way to shorthand recap how to read and present a visual on using function notation. Now you try with a different input. Hope you were successful with evaluating and presenting the graph to recap your story. So let's go over this together. This time, instead of using 1, our input is going to be 0. So just like in the previous example, everywhere we saw 0, we replace that with, everywhere we saw X, we replace that with 0. Doing the arithmetic, we should end with 2 as our output. So we're going to plot that right on our graph at 0, 2. And we can always go back and use that other point that we had of 1, 9. And it looks like I'm at 1, 8, so I am going to have to move that up. So I did not use the proper average rate of change of 7 over 1. So I'm going to make that adjustment. And then 2 points, always draw a line. Again, I always need that aid of that adjusted tool to ensure that my line goes through both points. And I can recap my storyline. So when I put the input this time of 0, I will yield an output of 2. Shows that in my algebraic, shows it on my graph. So you all are versed in telling a story using function notation. And this will help you when you have details including inputs, outputs, domain, and range. Hope you enjoyed the video and are now comfortable using function notation. Thank you.